Yeah. Okay, so that's our unit tangent vector. We've got to get our unit normal. And once we have that, we just do a cross product. And, you know, when I wrote this, I kind of automatically wrote an asterisk. There's no asterisk multiplication of vectors, right? There's dot product and there's cross product. Okay? That's all we got right now. So I should have written a cross there. That was careless. I looked at it several times and never saw that, but it's a cross product. So we got to do a cross product. But once we got the unit tangent and unit normal, okay, we easily get the binormal. I mean, we have ugly expressions, but the binormal's easy. Okay, well, what happens? To get the unit normal, we got to have our perpendicular, right? Our double prime perpendicular, okay? Or the perpendicular component of our acceleration, if you want to think of motion, okay? And to get that, how do we get that? Well, we got to have our double prime parallel, right? Now, if you go back to this picture, it's obvious what you've got to do. Your dot product is going to give you this, and you're going to subtract this from this, okay? And of course, you want to have that picture firmly in your mind in case you have brain freeze on a test. If you have the picture, it's more likely to come back to you in a bunch of symbols, okay? And if you do everything in terms of pictures and symbols, then when you need it, it's more likely to be there. Okay, so R double prime perpendicular equals R double prime minus R double prime parallel, which is R minus R double prime parallel is R double prime, I'm sorry, R double prime minus R double prime dot your unit tangent vector multiplied by your unit tangent vector. Okay? You know, that being essentially the magnitude of the component of your R double prime in your direction, but with the proviso that the dot product takes care of the fact that this thing might, you know, your acceleration might be in the direction opposite your direction of motion, as we talked about here. So it turns out to be a very easy calculation, but if you don't remember, as I say, what it means and where it came from, you're less likely to use it when you need it, or you're less likely to use it correctly even if you try to use it, okay? So, you know, this whole picture is a hedge against screwing it up, okay? Okay, so what do we have? Well, our R double prime, well, here it is, right? So I'm not going to write it out yet. But I will write out R double prime dot your unit tangent vector, right? Well, there's your unit tangent vector, there's your R double prime. It's going to be negative, well, it's going to be 0.8 cosine t sine t. Uh-oh. I'm going to get 0. I don't like it. I don't like it. Because there's no component there because you have no acceleration. I should have made it out of t squared, but that would have complicated this. It's okay. We'll do it anyway. Okay? I didn't think through something when I came up with the example, but okay. So in this case, it turns out to be very simple. So your R double prime perpendicular is your R double prime. In other words, your R double prime is perpendicular to your direction of motion. Although,
isn't that a circle though?
I've got a problem with that. Just visualizing it, it's obvious you're going in the helix. Your binormal is not vertical. And this disturbs me, so I'm going to turn off the tape and reconcile it, and then we'll figure out what I did wrong. Either I am imagining something wrong or I did something screwy with the calculations.